In a perfectly obvious sense, over the last 400 years or so there has been progress in science. Measurement of physical quantities becomes more precise, previously unknown particles and substances are discovered, new effects are produced and applied. Even if the ancients were wiser than us, and knew better how to live, they did not know the speed of light or the mass of the Earth or the structure of the hydrogen atom or how to produce and apply lasers. And we know now that, despite the brilliance of many of the observations, most of the theories of the universe described in Aristotle's writings are quite simply false. The Earth is not the center of the universe, nor do heavy bodies seek the center of the Earth as their natural resting place, nor is the Earth surrounded by series of circles on which the other heavenly bodies revolve. There is a striking contrast here between the development of modern science and the arts. No one would say of a work of music or literature that it was better than an earlier work just because it was later. A recent work by Luciano Berio is not, because of its modernity, better than Beethoven's violin concerto, and it would be just as hard to say that Brahms' violin concerto was better than Beethoven's. In contrast to the development of theories in modern science, a later masterpiece in a given artistic style is not thereby better than an earlier one, nor does it necessarily attain the aim of the style better, or anything of that sort. Indeed, in the case of violin concerto, it would be hard if not actually senseless to specify a target at which all violin concertos are aiming, and in relation to which one could say that concerto A got nearer to the target than concerto B. Leaving Berio aside, it hardly makes sense to say of Beethoven or Brahms that one is better than the other. There just is no scale on which one could judge such things, once a certain level of expressive adequacy has been reached. The case with scientific theories, though, is quite different. Here we are able to specify a clear target at which all theories aim, and we often have confidence that theory A has got closer to the target than theory B. The aim might be characterized as discovering the truth about the natural world, and when we have theories which aim to describe the same bits of the natural world, we can often say that a later theory is better than an earlier one. Thus Copernicus' sun-centered picture of the universe was better than Aristotle's earth-centered picture, and Newton provided a better account of the solar system and the universe than either. Similarly, every schoolchild now knows that the chemist Joseph Priestley mistakenly thought he had identified a substance he called phlogiston, a gas-like fluid with possibly negative weight which, among many other things, was given off when metal burned. We now know that there is no such thing and that there is no one substance that does all the things this imaginary element had been supposed to do. Priestley had actually been observing the effects of oxygen, which metals absorb from the air when burned, rather than those of the phlogiston they were supposed to give off. When he imagined he had isolated a sample of air without phlogiston, he had actually produced oxygen.